Yes, time travel might actually be possible, not just in science fiction, but in real science. Einstein's theories, black holes, wormholes, and even particle colliders all point toward one shocking truth. Time isn't fixed, it bends, stretches, and maybe it can be traveled. But would we survive it? And could it actually happen in the year 2025? Imagine stepping into a tunnel that drops you into ancient Rome, or leaping forward to witness humanity's distant descendants. Sounds crazy, right? Yet, the deeper we dig into physics, the more we realize our universe may already have hidden gateways. Let's break down the science, the theories, and the terrifying possibilities of time travel starting now. To understand time travel, we must first understand time itself. Albert Einstein's theory of relativity shattered the idea of absolute time. It showed that time slows down as you move faster and bends under intense gravity. If you could travel at 99.99% of the speed of light, about 299,000 kilometers per second, your personal clock would tick far slower than everyone else's. Astronauts on the International Space Station actually age microseconds less than us on Earth, for precisely this reason. But it's not just velocity. Gravity wells around neutron stars or black holes warp time so strongly that a few minutes near the event horizon could equal years back home. This effect, called gravitational time dilation, has been measured with atomic clocks on airplanes and satellites. So yes, forward time travel is scientifically proven, but it's a one-way street. You can't undo your trip. Jumping ahead is feasible, but to return to your starting date, that requires bending spacetime into a loop, a far trickier challenge. Going backward in time demands what physicists call a closed time-like curve, essentially a loop in the fabric of spacetime. One theoretical route uses wormholes, hypothetical tunnels connecting distant points in the universe. If one mouth of a wormhole is accelerated to near light speed and then brought back, time dilation at the mouth could create a time difference between the two ends. Enter one side and exit at an earlier date. Nobel laureate Kip Thorne and Stephen Hawking even explored the math behind these exotic structures. Then Hawking mockingly held a time traveler party where he sent invitations after the event. No one showed up. Was that proof backward travel is impossible? Or just a sign no one from the future could safely traverse a wormhole? Beyond relativity, quantum mechanics hints at ever-branching timelines and parallel universes. In some models, changing history simply creates a new timeline, leaving your original past intact. But this many worlds interpretation raises mind-bending questions. If you kill your ancestor in one branch, you still exist in another. Ultimately, no experiment has ever confirmed backward travel, and paradoxes like the grandfather paradox remain unsolved. Even if the physics check out, could any living being survive the journey? Accelerating a vessel to relativistic speeds exposes its occupants to immense g-forces, forces that would literally crush bones and organs unless somehow counteracted. Radiation from cosmic rays and particle collisions at near light speeds would bombard the ship with deadly energy. Wormholes pose their own hazards. Without a stabilizing form of negative energy, they collapse almost instantly. And negative energy itself is purely theoretical so far, only glimpsed in tiny quantum effects like the Casimir force. Let's say we master exotic materials and build a stable wormhole mouth. Traveling through the tunnel could still tear you apart if tidal forces differ too much between entry and exit. And even if you emerge intact, your molecular structure might be irreversibly scrambled, immune systems destroyed, DNA ruptured. Then there is the psychological toll. Emerging in a world centuries different from your own could induce severe disorientation, delirium, or extreme culture shock. The more we probe, the more it looks like surviving time travel is as big a challenge as achieving it. So can we build a time machine right now? In 2025, the short answer, not yet. But cracks are forming. The Large Hadron Collider smashes particles at energies never before seen, creating fleeting conditions similar to the universe's earliest moments. Some researchers claim hints of microscopic black holes or time-like anomalies in these collisions, though nothing confirmed. Meanwhile, Quantum computing platforms are exploring time crystals, phases of matter that repeat in time rather than space, hinting at new ways to manipulate temporal properties. NASA and private companies are planning vessels that travel deeper into Earth's gravity wells, seeking extreme time dilation effects. And an unlikely community of amateur chrononauts publishes fringe papers on DIY wormhole generators, none peer-reviewed, but fueling public fascination. In short, the foundational tools, particle accelerators, quantum labs, and gravitational wave observatories exist today. We might not step into a DeLorean tomorrow, but the physics experiments of 2025 could reveal new doors. So, is time travel possible? Yes, forward travel via relativity has been proven, and backward travel remains a tantalizing theoretical possibility through wormholes, quantum effects, or undiscovered physics. But even if the universe allows it, practical hurdles, G-forces, radiation, exotic matter, paradoxes, and human survival loom enormous. The real takeaway, our understanding of time, is still in its infancy. Every advance in physics brings us closer to new wonders, but also new mysteries. If this deep dive ignited your imagination, subscribe now to feed the mind for more explorations at the edge of science. Hit the bell icon so you never miss a mind-bending journey, because the future, past, and present are waiting to be discovered.